Hi guys, welcome to the channel, and today we are going to work on a problem on trees. So you have the problem statement here. It's a lead code 199 problem. So what it says, given the root of a binary tree, imagine yourself standing on the right side of it. So we'll see like the right side and return the values of the nodes. You can see order from top to bottom. Okay, so given the root will be given and we have to give an output as in like what all nodes will be visible from a specific angle. So let me just, you could see here. So what happens is you have one which has a left and right node. So how we are taking left and right is your viewing angle. When you are viewing this image from, you could see here, this is towards your left, right, left, right. So how we have how the tree is constructed is one has node 2 and 3. We could see 2 and 3, and then 2 has null and 5. So there we don't have any left node. 5, and then again 3 has null and 4. Okay, so if you are viewing the tree from the right side, okay, so what all nodes you could see? 1, 3, 4. Okay, so assume another scenario when this node is not there. So in that case, what all you could see? 1, 2, 5. So what I have, so what I'm doing is I'm just creating a node class, a simple node class which has data and it has respective right and left initialization method. Here what I have done is left and right by default I have made it nil, right nil. I'll tell you why, and then you assign it. So here I have, this is the method which we are going to write, and here I am creating root. So root, how I am creating, the first value is 1, so you give 1. 1 has a left node, 2 which has a right node, 5. So let me go back to that example again, image. So 1 which has 2 and which has 5, and if I press command Z, and again the right is 3 and which has 4. So if I do now print a right side view for my root 1, so what it should have? Empty array. Okay, let's get started. So what I'm doing is, the very first thing I need to check if my root is available. Okay, so how I can check? Let me put a guard statement. I'll say let root equal to root, else you return an empty array. Okay, so what I'm doing is I'm making sure my root is available here. Once I have the root, what I need, another thing is I need a var which will store my result. Okay, so result will be the data values, so it is of type int. I'll initialize it to empty. So what do we need in the result? The value. So here 1, 3, 4. And what else I need? So I'll take a queue to save, to iterate all the nodes. So what it will have nodes, and I'll initialize it with my root. So right now it just has the root, and now what we need to do, so have a basic setup done. So what I'll do is I'll say while my queue is empty. Okay, I'll iterate through it. So the idea how we will go about it, so let me show you. So now if I have this side by side, so result should have the final value which is 1, 3, 4. How I will get that final values? So I have to iterate through each level. So how we will do each level, how we will iterate through each level? If I have to give you a context, so here when we are iterating through first level, our queue should have 1, When I am iterating through second level, it should have 2 and 3. When I am coming to third level, it should have 5 and 4. Simple. So in this case, what I would be doing is, what I have to pick is the rightmost. I will take this, I will take this, I'll take this. Clear? So my queue should iterate through each level. So first level it is here, second level here, third level here. So that's why I have a condition called queue is not empty. Right now it is not empty. Why? Because we have node value saved. Okay. And inside what we need to do is, it can be one, it can be more than one, correct? So let me iterate through all the values. So for, okay, in 0, which should be less than my size. Okay, so how you would get the size is my queue. So queue dot count. Perfect. So you get the context, like while will make sure my queue is not empty. So inside this part we have to append, because the first time only it has this, next time it should have this, the next time it should have this. So let's do this quickly. So what I will do is, let me take that var, I will say write most node data, which is equal to -1. So what is rightmost node data? In this case it is 1, in this case it is 3, in this case it is 4. Okay, so while iterating, what I have to make sure is, let me take my node. Okay, so let's remove first. Okay, so what we will do here is now rightmost node data. Okay, it is basically node dot data. So what we are getting here is 1. What we have to do after that, we will check if my node, so what we are reached here, I will check if my node has a left is not nil. So I'll give my append my queue with this value. If not, then I'll append with this node. So simple enough. What we will do here, we will just append. So I'll take my queue dot append with which node I have to take, node dot left. Okay, and here what I will do, append node dot right. So we get that. What we are doing is, in queue we are having node dot left. In queue, if right is not empty, we are adding right. So simple enough. What we are doing is, we are getting the rightmost node value, which is 1, and then we are checking if 2 and 3, which is left and right node, which are not empty, we are adding 2 and 3. So you could see here, when we do first element, there is nothing in the queue. Then we have this. So in the second iteration, we would have 2 and 3. Okay. So now what we need to do, and you could see here, in every iteration, we are making the rightmost node value equal to -1. So here it is -1. We'll iterate through and we'll have a value. Then 2, 3 will iterate and we'll have a value 3. Then 5, 4 will have a value 4. Once we are outside for loop, we will do result dot append my rightmost node data, and I will return my result. Okay, so what I have done here is, I have created a root, and we'll see what does it print in this case. In the answer we have 1, 3, 4. Okay, so if I have to show you the picture I was referring to, 1, 3, 4. So now assume if I don't have 4 now. So in that case, from this angle, what will be visible? 1, 3, 5. So let me just append my node. My node has 4. So I'll say my node doesn't have 4. So if I make this change, my node is, my tree is something like, my tree is something like this. So what is visible from here? 1 3 5. So let me quickly run. What we are doing is we are going on every level. Okay, we are here for the first time, we give this value, and then we keep on checking until our queue is not empty. And what we are doing is we are iterating through all the levels. So here, when I go to the second level, this node has left and right children. I'll put that in a queue, remove this. So now we are on second level. I'll iterate through. So if this number is big also, it will still iterate. And then again, it will go through this and iterate through this. Okay, so you can, what to do next, you can find this code on GitHub. I will have the link to the code attached in the description. You can play around, you can create your own trees and see if this algorithm works for you. So quickly going to the complexity of appending in the queue will have a complexity of 1, because we are just appending it. And here again we have of 1. Okay, and queue count we are going through, this is number of elements in the queue. We'll go through every element. So this is of n. Basically it will iterate through all the elements and remove first. If I control command go through this should have complexity of O(n). Yeah, so here we have complexity O(n), where n is the length of the collection. So this is it for the video. I hope this is useful, and if you think there are any modifications or any improvements can be done in the existing solution, please let me know in the comment. And thank you. I'll see you in the next video. Bye bye.